Alright, what is up, guys? So this is the start of first unit for Algebra 2. I'm going to be demonstrating all of Algebra 2. So I'm just going to, before we start, I'm going to give a quick, kind of summary of what the first unit of Algebra 2 is about. So you start off, what we're going to do today. We're going to learn linear functions. Then we're going to do correlation on a scatter plot. And then after that, we're going to do exponential functions, then quadratic functions, and then we're going to go to piecewise, which is very annoying. These are not the best drawings, but I'm just trying to give a general idea of what they're like. So yeah, first unit, we're going to be covering kind of review of Algebra 1, where you learn all the important things that you need to know in order to go through Algebra 2. Because most of people that went through Algebra 1 had to go through geometry after and kind of is a little rusty about this. So today we're going to go over linear functions. So we can build our understanding and get ready to learn about correlation. So first thing you need to know is kind of the general idea of what a linear function is. So I got linear right here. First thing you need to know is that I'm going to type this down, make this big, is a linear function is an infinite straight line on a coordinate plane. That's it. That's basically that's pretty simple, kind of easy to grasp and understand. That's what the definition of a linear function is. And now the other thing you also need to know is that a linear function is kind of more not the definition, but it's a feature of it. A linear function always has a constant rate of change. So what that means is that every time it crosses over the x once, it's always going to say the slope is 3. Every time it crosses over an x, it's going to the right is going to go up 3. If it goes 1 to the left, it's going to go down 3. That's a basic, always constant rate of change. It's never going to go up to 4 unless you transform it, but we'll get into that later on. But yeah, that's kind of simple idea of what a linear function is. The first thing you need to know about linear functions are the 3 main forms of it. So the first main form is something you probably learned in 8th and 9th grade. This is probably the most important, slope-intercept form. So slope-intercept form is pretty basic. It's y equals mx plus b. So let's start off with the x. The x is the input. So usually whatever you put in for the x as the input is what's going to help you solve this equation. The m is the slope. So it depends on how much up or down it goes. So if it's -3, that means it goes down -3 every time the x goes up by 1. And the y here is the output. So that's what you get as a result for for solving this by plugging in the x. And the b is the y-intercept. So what that means is that basically when the x equals 0, since you're multiplying it with m, it will cancel out because 0 times anything 0, and it will be left over with b. So y will equal b, which means that's the y-intercept. So when it crosses the y-axis on a coordinate plane, that's the point it's going to be. So if it's 7, that means it crosses the point 0, 7 on the coordinate plane. The second form that you need to know is standard form. So standard form has the equation ax plus by equals c. So there's not really much to this. The only thing is that if you subtract the ax and then divide b to single it out, You can get it to become y equals mx plus b form, but usually standard form is really, when I say really, I mean it is super useful in word problems. Usually, unless the teacher or the question specifically asks to, usually you make a word problem into standard form, which is why it's such an important one. So this third one isn't exactly something that you would use to display, but this is more to kind of help find a b value, because it's called point slope form. So what point slope form is, it's y minus y1 equals m parentheses x minus x1. So these are the three main forms. So in order to do this, you don't use this y or the x for anything, but the y1, x1 is usually the coordinates to a point, because you need a point that's in the line and the slope in order to find out the b value, so you could solve it and turn it into slope-intercept form, which it's really useful, but it's kind of annoying. I personally don't like it, but later on when we're going to start analyzing absolute values, this is going to be super useful. The next thing you need to know is kind of like, we're going to analyze a linear function and like kind of solve it, convert it to different forms. So we're going to use this coordinate plane. It's not going to be a perfect graph, but it's more of like a reference to show the idea of what the function is like. So let's do as an equation y equals 3x minus 9. That looks like a G. But, yeah, that's a 9. So y equals 3x minus 9. So things you need to know is that the 3 is the slope. So every time you cross over an x-axis by 1, you're going to get that slope as 3. And this negative 9 is the y-intercept. So when x equals 0, then the point would be negative 9. So it's probably somewhere be around here and then go up like that, because the positive slope. So if it was a negative slope, it would go down like that way. But you probably already know that from Algebra 1. So let's kind of more understand how this works. So what we're going to do is that we're going to convert it. Imagine we don't know what this y-intercept is at all, and we only have the slope. We're going to use a point and plug it into point slope form so we can understand that. So the point we're going to be using is 0, negative 9, which is the y-intercept. Of course, you usually won't know that. They'll give you a point on exams, usually, most of the time, like 99% of the time, actually. So let's plug this into point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. Excuse my handwriting. So yeah, let's plug that in. So we have y, so minus y1. Since this is normally minus, we have negative. Those two will cancel out and create a plus. So we would have y plus 9 equals 3, because that's the slope, 3 times x minus 0. So first thing you have to do is that you need to distribute this. Distributive property goes into all of them. So you have y plus 9 equals, since this will go into 0, that doesn't matter. So we just have 3x. So now what we do is that we subtract 9 from y. So you'd isolate it. So y equals 3x plus 9. So that's kind of like what the premise of point slope form is for. You take the slope and then point and you plug it in, do all that annoying stuff, and yeah, you would get the it would convert to y-intercept form if you solve it. and do all that basic stuff. There's also another thing to point out. Sometimes on word problems, they won't give you slope-intercept form, and they would only give you the standard form. So this, for example, for this, it would be 3x minus y equals 9. So what we would do first is that we need to isolate the y. We need to get the y by itself so it could be like this. So we would subtract 3x on both sides. So this would cancel out. So we'd have negative y equals negative 3x plus 9. And since this negative y actually has a coefficient of negative 1, because that's negative 1 times y, you would also cancel this out with negative 1. So this would become positive. So y equals, and then negative 3 divided by negative 1 is 3. So 3x minus 9. So that's important to know, because sometimes they will give you an equation standard form, and you need to know how to convert it into slope-intercept form, because that is super duper important. All right, the next thing that you need to know, which is super important, is how to find the m. So there is a formula to finding m, just like y equals mx plus b, y minus y1 equals m times x minus x1, and etc., etc. So to find the m, it will be m equals y2 minus y1 divided by x2 minus x1. So usually when you're doing this, they will give you you need 2 coordinates in order to do this. And we're going to go back and use that same function from last time. So as the coordinates, we're going to use y-intercept like last time, 0, negative 9. And we would also we're going to use 3, 0. Easy stuff. So now we need to plug these two into y2 minus y1 over x2 minus x1. So for reference, we're going to make this 0.2 and we're going to make this 0.1. So we're going to do m equals, we're going to take y2, which is negative 9. So negative 9 minus, we're going to take the first y, so that's 0, divided by, then we're going to go back here, 0 minus 3. So that will equal us negative 9 over negative 3. And then we do some simple division and you get 3. So m equals 3. But now, say we need to convert this into y-intercept form. So we would do the same thing, just like with point slope form, where you could take one of the coordinates and plug it in, just like how I showed you last time. But I'm just showing you this because this is important to know. That is it for today. This unit 1, we're going to kind of breeze through until we get to piecewise. That might be that in exponential, because that is some stuff that some people may have not learned in Algebra 1. So we'll kind of concentrate on that more. Next, we might do correlation. I'm still thinking about it because it's pretty troubling to do. But I'll also demonstrate exponential and who knows. So I'll see you guys later. Make sure to like and subscribe, and I hope you enjoyed this lesson.